Married Monday, the 2nd of November, the first Monday of the month, okay? Geometry, SWBA students will be able to make rotations on a graph. So we're going to take this graph, we're going to take these, and we're going to rotate, okay? So, rotations. It is a turn around a fixed point called the center of rotation. A turn around a fixed point called the center of rotation. Now, the figure rotates at a specific angle. Let's see what's rains down in Africa. Let's forget. And direction, either clockwise or counterclockwise. Now, we will only be doing the counterclockwise, but they can go either direction, okay? So we're only going to be going counterclockwise. So clockwise would be the direction a clock goes, okay? So it'd be going like this, okay? And counterclockwise would be the other direction, right? Okay, we kind of see this arrow here going to the left. So here are some rules for doing this, okay? And I want you to write them down exactly how I have them, okay? Does that make sense? If you don't write these down, you're going to be lost, okay? I'll answer your question in one moment, Seth. For 90 degrees, if you take your original x, y, it yields negative y, x. You switch the spots, only the y becomes negative. We'll talk about why that is in a moment. Okay, but you switch the spots, and only the y becomes negative. Okay. For 180 degrees, your original x, y will yield y, x. Or excuse me, I mix that around. Negative x, negative y. You don't switch spots, but they both become negative. And 270 degrees, your x, y will yield y, negative x. You switch the spots again, but now only the x becomes negative. It's kind of the opposite of what you did at 90 degrees, right? You switch the spots, y became negative 90, but now you switch spots and x becomes negative in the 270. So in 90 and 180, you flip them and you make one negative. In 90 to 70, you flip them and make one of them negative. But in 180, you don't flip them. Instead, you make both negative. Okay? Yes, Kenny.
Do you always rotate it over the midpoint?
We are only going to focus on rotating it around the origin. We're only going to focus on rotating around the origin as our center of rotation. That's what these rules are good for. These rules would not be helpful if you're rotating around a different point. Great question. Okay. We'd have to change our rules for that. Seth.
So you could have like a point on 0, comma something else.
You could have a point there. We'll see how that would move, okay? Now, guys, to make this easier on you guys for this, because this ends up being a lot of memorization, I have a foldable for you guys.
Let's go.
There we go.
Let's go.
Okay.
Do you have scissors?
I'll cut or go around and cut them.
Alright, bad. Why would I need this? What do you mean, why do you need this? Why do you need me? Why would I need this? It's a foldable, dog.
I don't have all of it printed,
He said
but I
it
have you
looks
guys
simple, but it's not.
Good. I'll forgive you this time.
Were you not paying attention?
You're good at coding. Bad.
Blue here.
Okay, so here's what we'll do with this foldable, okay? Everyone have it in front of you. Okay? You're going to fold it hot dog style with these 90 degrees, 180 degrees, 270 degrees being on the outside. So you're going to fold it hot dog style with that being on the outside, okay? So the blank and the, so one side will end up being blank after you fold it hot dog style.
It's okay, Seth, you know me. I can't fold at all. You're doing it the wrong way. Already folded right now.
Okay? And then what we will do is I'm going to go around and cut these for you guys along the dashed lines. Now I don't have any glue for you today, but if you want to later on, you could staple or tape these during our work time, okay? Where it says glue here on the back side, okay? Does that make sense? Okay. If you want, you can just kind of make a big crease there. This is under the 90-degree rotation, so the far left. So our rule for this, which we wrote down once already, x comma y yields negative y comma positive x. Negative y comma positive x. Go and write that down again in our foldable.
I know I'm gonna get number 4 wrong.
Okay. Now we're trying to graph this triangle ABC with vertices A, B, and C. And then we're going to do its image after a 90-degree rotation. So our first step is to graph the triangle. Just like on every problem, our first step is to graph the original shape. So go ahead and graph this original shape of ABC. Or excuse me, triangle ABC. You want to go ahead and write late on there, buddy? You want to write late on it?
Yeah.
No, you don't have to. Okay. So 2 comma 1 will be point A. B's at 3 comma 8.
3 comma 8.
Yes, and C's at 7 comma 2.
Yeah.
You don't need to excuse yourself after your yawn. Okay?
Why do you put C like right on the thing?
Oh, excuse me, I did that wrong, didn't I? Good catch, Gregory. Alrighty, I like it. I caught that. That's clever. Okay. So now we're doing a 90-degree rotation. So we're doing negative y comma x. So we're switching the spots. So instead of 2 comma 1, we're going to put the 1 where the x goes, because that's where and then we're supposed to be at negative. So it's negative 1 comma 2. So it ends up being negative 1 comma 2, and I'm actually going to change color on this.
Oh, this makes sense.
Okay, so I'm going to go negative 1 comma 2, and this is going to be my A prime. My B, instead of being 3 comma 8, it's going to be negative 8 comma 3. We switch the spots, and whatever was the y is our new x, and we make it the opposite sign.
Why is your C on all of them? Wait.
So C on 7 comma 2, raise your hand if you can tell me what that would become. Seth?
It would be negative 2, 7.
Negative 2 comma 7. Very good. So in the orange, we have our new image after this rotation. In the orange, we have our new image after this rotation, okay? Does that make sense? So is a triangle facing the same direction anymore?
No.
No, because we rotated it, okay? We didn't just pick it up and move it. We rotated it, okay? So it's not like cut and paste, okay? It'd be a lot like this, okay, guys? This stool right now is normal, right? So it'd be like if I did this. Okay? Now we have a 90-degree rotation. Okay? Now we have a 90-degree rotation. Okay? It was just on its side from where it was before, okay? Does that make sense? Okay?
Wait.
No.
Cleo, might want to put headphones on. Okay? Continuing on. Let's look at 180 degrees. X comma y will yield negative x comma negative y. Okay, we'll yield negative x comma negative y. So we're going to graph this triangle XYZ with the points. So go ahead and plot those points for triangle XYZ.
Will we ever have to rotate these? Will they ever end up off the graph?
They shouldn't.
Hopefully not.
If they start on the graph, they're going to end on the graph.
Okay,
They start off the graph, they're gonna end off the graph.
I believe you. Not you said that. I couldn't care less what you had to say.
Kudos to you for using the correct form. A lot of people say I could care less, which is just silly because that implies that you care a bit already.
It bothers me. It's like, well, then it's like.
Okay, so if this is my original triangle, x comma y or x y z, x is negative 5 comma negative 1. What would my x prime be if I rotated 180 degrees?
5, 1.
5 comma 1. They don't switch spots, but they both become negative. But they already were negative, so the negative of a negative is a positive, just like the enemy of my enemy is my friend.
What? No.
You guys ever heard that phrase?
Yeah, but I have. It's not true. That's not how that works.
Sometimes it is.
No.
Depending. Okay. Y is negative 7 comma 6. What is y prime?
Positive 6, negative 7.
Nope. 7 negative 6. You don't switch spots, but they both become the opposite signs. Kenny, no. Z is negative 1 comma 2. What is z prime?
1, negative 2.
1 negative 2. You just switch the signs. So does it end up looking as if you had just taken this shape and rotated it around the origin?
Yes.
If you took it and you kind of rotated it around, okay? So if like Presley and I are both holding a string right now, okay? And she stays still. Okay, right now I'm facing toward her, right? Okay, and I rotate around holding the string, I'm still going to be facing toward her. If I rotate around holding the string, I'm going to lift it up so I don't, drop your head off from
Well, at
the
least
back.
that
Okay?
example was a
Then
lot
I'm going
less
to be over
point
here.
than the last one.
Okay, does that make sense?
You pretty much
Just.
you just wrapped her with string.
Okay, so it'd be like my stool being like this,
Oh no.
Please don't.
and that'd be 90 degrees,
Kick it some more.
and that'd be 180. Okay, it's still the same stool, it's just facing a different
I'm
direction.
pretty sure if you take it hard enough, you'll most likely flip it.
Yeah.
Well, let's try it.
No!
Then, make it harder.
Okay, let's go on to this last one. 270 degrees. So x comma y will yield y comma negative x. And these are the same things we wrote down a moment ago. We have the triangle PQR with the vertices P, Q, and R. Go ahead and graph those. Go and plot those points and then graph the triangle. Okay. So negative 8 comma negative 5 is P. Negative 6 comma 0. So Kenny, this is what I was talking about. We're going to have one on an axis, okay? And negative 2 comma negative 1. Is that what you were asking about earlier, Kenny?
Yeah, sort of. I want to know if it, like, you never have to turn it and it would end up, like, 1 point off the graph.
Oh. Which I already answered earlier, right?
Yeah.
Okay, Seth.
Did you ever have one starting at the origin itself?
Yeah. Just the one on the origin would move, right? Okay. So if we're moving this 270 degrees counterclockwise, it starts here if you look up at the board. 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 Okay, if you look up at the board. There we go. Starts here. This would be 90. This would be 180. This would be 270. What would happen if we did a 360 degree rotation? It's the same as where it was, okay? So 90, 180, 270. So it should end up over here, right? Okay, let's look what happens. So y comma negative x. So P is negative 8 comma negative 5. Becomes negative 5, positive 8. The y doesn't change the sign, it just changes spots. The x changes both signs and spots. I'm actually going to do that in a different color.
Do it brown.
So negative 5 comma 8 would be my P prime. Q, negative 6 comma 0 becomes what?
0,6.
0 comma 6.
It's simple as that.
So my Q prime is up here. R, negative 2 comma negative 1 becomes what?
2,
Negative 1 comma 2. Very good, Christian. 1 to the left, 2 up. Thank you. So does that end up looking like that?
Yeah. Yes.
Okay. It does end up looking like it was just rotated around. R is still the closest point, Q is still on an axis, and P is still on an axis over here, okay? On the edge of the graph. Now, if you were to take your paper, guys, and you have your original shape here, and I rotate it around 270 degrees, it should look the same, really, relatively speaking, okay? So if you have it normally, Q's on the top and it's touching the axis that's running along the top for us. And P's on the far left of the graph. And if I rotate around 270 degrees, Q is still running on an axis above it, in the middle of a graph. P's still on the far left and R's on the right. So does it end up really looking the same? It's just in a different spot now. But if we rotate our paper around the same amount, we end up getting the same thing, okay? 270 would be 90 the other direction, right? Okay. So if on my stool here, you guys ready?
Yeah.
Okay. That'd be 90.
Please, no.
That'd be 180.
Please, no.
That'd be 270.
This is 90.
Okay. It's still the same stool. It's as if I had taken the stool and done it 90 the other direction. Okay. It's as if I had taken the stool and done 90 the other direction. Okay.
We're still not annoying.
What?
Still not annoying.
What?
I'm sure this reminds me about you.
Seth, we can all do the same thing for you.
Okay.
You're 10 times worse than Mr. Collins.
Okay.
We actually
Are you saying this about
No.
Okay. Hey guys, stop. Okay. We're done with the stool for today. Calm down. Okay. Okay. I don't think of myself that highly. Okay. So. Oh. Okay. So. The 90 degree. What ends up being our new x ends up becoming negative, because if we start up here in the top right, we end up putting it in the top left quadrant. So if we start in the top right, we end up moving it to the top left quadrant. So the x values are all negative in this quadrant, but the y values are positive. So what ends up in the x spot is negative. What ends up in the y spot is positive. 270, the x stays positive, so what ends up in the x spot stays positive, even though it's the y values. What ends up in the x spot is positive, and what ends up in the y spot is negative. Okay? So it's about what ends up there ends up being this value. Let's try some examples. I want you guys to try number 1 on your own. When you have it or have questions, raise your hand. And keep referring back to this foldable. Okay. So we have our original 2, 7, 6, 5, and 4, 1. Now we're doing a 90 degrees clockwise or counterclockwise rotation. So x, y will yield negative y, x. So instead of 2, 7, we're going to have negative 7, 2. Instead of 6, 5, negative 5, 6. And instead of 4, 1, negative 1, 4. And we'll graph these. Now you might notice that some of us have an easier time doing this visually rather than starting with the numbers. For example, Tony did a really good job he had the triangles both graphed. He was like, but how do I figure out what the points are, right? Tony, is that what you're saying? Okay. So Tony, I'm guessing, correct me if I'm wrong, okay? But Tony, I'm guessing what you did was you just saw this and you said visually, oh, if we're doing it rotating here, it's going to end up here, and you just did the shape, right? Did you turn your paper maybe? No? You just kind of visually got it? That's awesome. I struggle with that, but some people do really well with that, like Tony, for example, here. And then, so he said, oh, okay, well, this would be my b up at the top. And what are the coordinates? Oh, okay, -5, 6. Okay, and Tony, did you end up getting these right? Yeah. So is there more than one way to do these? Totally, okay? So you don't have to do it the way I'm doing it. If you have something that works, that's awesome. I'm so happy for you, okay? I want you to have something that works, okay? Questions on that? Okay? Go ahead and try number 2 if you haven't yet. And when you have it or have questions, raise your hand. So we have the square PQRS. See, P is going to be up here. Q is over here. R is down here. And S is over here. And now we're rotating 180 degrees. So for the 180 degree rotation, you don't switch spots, but you make them both negative. So 2, 6 is -2, -6. -6, -5. -5, -1. And -1, -2. Now we can also think to ourselves, hey, before we start this problem, if I'm starting in the top right and I'm doing 180 rotation, where should my picture end up? If I'm starting in the top right and I'm doing 180 degree rotation, where should my picture end up?
In the 4th quadrant.
In the 3rd quadrant in the bottom left. Okay? So let's double check that this is what happens. So -2, -6. P prime. Q prime is -6, -5. R prime is -5, -1. And then -1, -2 is S prime. And it does end up in that quadrant, which is a good sign. Questions on that? Alrighty, here's what I want. I want you to give me a thumbs up if you're feeling good about these, thumbs down if you're not. Okay, be honest with me. Thumbs up if you're feeling good about these, thumbs down if you're not. Okay, I want us to do number 10. Scratch that, we're doing number 11. We're doing 11. I said number 10, we're doing 11.
I'm getting confused.
Okay, what?
I'm getting confused already.
I thought you said you were good.
I still won't get it and do not get it.
There's only ups and downs.
Why is there no sideways?
Not for me, there's no.
So on 11, we have D at 4, 5. E at 6, -2. And F at 1, -2. And for this, we're rotating 270 degrees counterclockwise, so we're doing X, Y. Yields positive Y, -X. So 4, 5 becomes 5, -4. 6, -2 becomes -2, -6. And 1, -2 becomes -2, -1. So if I graph all of these, I end up getting this triangle. So the X's changed the spot, Y's changed the spot, but the Y's did not change the sign as they moved into the X spot, but the X's changed the sign as they moved into the Y spot.